Hi everyone, Mr. Rodriguez here with another video for you guys. So our objective for today is students will be able to plot and interpret regions created by inequality graphs. So we're going to be plotting inequality lines on a graph, and we're going to be seeing what regions they create. Now, before you do inequality graphs, you have to make sure you know how to plot basic lines. So in the Google Classroom, you should see within this lesson a little review video from Khan Academy on how to plot lines if you need a refresher on that. Again, that video is entirely optional, but you should watch that if you don't remember how to plot lines. Okay, so assuming you do know how to plot lines, we can start looking at the notes for today. So for our first problem here, it asks us to graph each system of inequality. So a system of inequalities is basically just a set or a group of equations that will form some specific region on the coordinate plane. So you see how you have two equations, right? 1, 2. And then those equations are going to form some kind of region on the coordinate plane that we'll be able to shade in. So the first thing we want to do is we want to just graph each of those equations. So first equation is y is greater than or equal to 1. So the way we solve that is we have our y-axis up here and our x-axis over here. So what we do is we find 1 on the y-axis, right? That's right here. And so the line, right, y is greater than or equal to 1 would be like that. And again, because it's or equal to, right? Remember, this symbol means it's greater than or equal to. That means we keep, we basically represent that by just keeping this one long continuous line, because we're saying that it could include points on the line itself. But again, since this is an inequality graph, if we're looking for all of the points that where y is greater than 1, then it's going to be all the points up here, right? So it's all the points above that line, right? If it was y is less than or greater than 1, then the points would be down here on the bottom, right? And then let's look at our next equation. So for our next one, we have x is less than or equal to 5. So again, we look at our x-axis and we count 5. 1, 2, 3, 4, 5. So then we draw a line right here. But this time, we're looking for any points where x is less than 5. So x is less than 5 over here, right? All on this left side of the line, right? So then our solution, or our region that we were searching for, is basically just the region that intersects the red region and the blue region, right? So we see here is where there's both the blue region and the red region, right? It's where the two different planes intersect. So this is kind of like our answer in some ways, right? That's the region we were looking for. So our first little question here, I, is the point 1 to a solution? So again, just to clarify, this is our origin, right? And it's a solution if the point lies within this purple circle, right? So 1, 2, would be over 1 up 2. So that would be right here. And we can clearly see that this point does lie within this region, right? It's in the part of the coordinate plane where the two regions intersect. So you'd say yes. Is 1, 1 a solution now? So 1, 1 is over 1 up 1. So we actually see this is right on the border, right? You see how it's on this blue line we made originally? That y is greater than or equal to 1 line. So because we're using this specific symbol here, right? The greater than or equals to symbol, that means this point is a solution. It is within the region, it's including the lines, right? If this were just greater than 1 instead of greater than or equal to, then it would not actually include that point there because we would not be including the line itself, only everything above it. So for our little part 3 here, the region is the intersection of how many half planes. So bit of a weird maybe vocab here, but basically what we mean by a half plane is you see like originally, right, when we made our blue line, our blue horizontal line, you see how we shaded in everything above it, but not below it. So that was like 1 half plane, right? And then again, if you look at our red line, you see how we shaded everything to the left, but not to the right. So again, that's like another half plane. So you'll notice we only use 2 half planes, right, for our solution, right? So it's just 2 half planes. If you're doing this on a PDF or by hand, you can just kind of draw in the coordinate plane and the lines themselves. You don't have to use different colors or anything. If you're doing this on a Google Doc, there's not really an easy way to shade, to draw this. So the answers are fine for a Google Doc. So just because it's a little hard to draw everything over here. So let's look again down here at B. So the formatting is a little weird because the equation's up here, but these are the questions. So we have, again, 2 equations. So we have y is less than 2x plus 1. And we have y is greater than or equal to negative 3x minus 2. So the first thing we want to do is, again, just graph our lines. So y is less than 2x plus 1. So again, the first thing we do is we just plot the line 2x plus 1. So for 2x plus 1, we know plus 1 is our y-intercept, right? So we know that this point is going to be there, right? And then if it's 2x, 2 is our slope. So that means we are going to be rise over run, right? Y over x. So that means we're going to be going up 2 and right 1, right? So then our line would look basically like this. If I can kind of connect them. Right? So that's our line. And this time it's just less than 2x plus 1, right? So we're going to do, for any y values that are less than the y values on this line we made. So that basically just means any region that's below the line, right? And usually there's some way to indicate on the line that we're talking about, that we're not including the line itself. So let's see if I can do that. I'm not sure if there's an easy way. I'm not sure how to do this on this PDF editor, so I'll just do it this way. See if I make little maybe like dashes on the line like that. Usually they kind of like erase little parts of the line, so it's like a dashed line. But this will suffice. So if I draw this kind of line, that means we're not including the line itself. And then let's look at our other equation. Our other one is y is greater than or equal to negative 3x plus 2. So again, we're going to graph this line. So basically we're graphing the line y equals negative 3x minus 2. So again, this time our y-intercept is going to be down here. And if it's negative 3x now, right, negative 3 is our slope. So that means we're going to be going down 3, right? Negative means down and over 1. So it'll be down 3 over 1. And then, you know, when you're going up here, you kind of do the reverse, right? So this is kind of like down 3 over 1, right? Like that, right? And then the last one would be somewhere up there. And then if you draw this line, whoops, oh wow, looks okay. And then this time we have y is greater than this line. So we want everything that's above this line. So this would be all of this, and then over here too, right? So we have this section over here that's kind of not, does not intersect the blue region, right? But then everything over here, right, intersects with the blue region. So you kind of have to imagine it's like, it's everything that's like right of the blue line, right? And then again, down here we have a small section where it's just blue, right? Because this would be below a red line, right? So our solution then, again, if I just kind of try to circle it in purple, it's kind of like over here, right? Kind of see that? So then again, let's look at our little questions. Okay. So is negative 2, 4 in the solution set? So again, we look at our origin. And negative 2, 4 would be left 2, up 4. So that would be this point over here. Now, it might be tempting to say it is in the solution set, right? Because it's kind of like on our red line. But again, for it to be in the solution, it has to be in the region where both of the two regions we made intersect. So this is not a solution. And is 1, 3 in the solution set? Again, let's take a little look. 1, 3. So again, we start at our origin here. We go 1 and then up 3. I know it's getting a little messy here, but if we kind of zoom in, so 1, 3 is up here. Notice it's on this blue line we made, right? Now the issue here is, if you remember, if it's on the blue line here, because our blue line again was this first equation, right? You see how it's not an or equal than symbol? It's just less than. That means we're not including what's on the line. So this would actually, 1, 3 would also not be in the solution set. And again, how many half planes do we have? Again, since we only used 2 lines basically, we just have 2 half planes, right? Okay, let's look at our next problem here. So this time we actually have a graph for us already. We have this kind of long rectangle. And it says, name 3 points in the interior of the region. So the interior of the region is basically anything inside the rectangle. So we could just say, right, this would be a point inside the rectangle, this would be a point, and that would be a point, right? So we could say, let's say, what do we have here? 4, 3. We also have 4, 10. And 4, 17. Next one is name 3 points on the boundary. Now this time, the boundary specifically refers to the edges, right? The line. So we see kind of like the border, right, of the rectangle. So these points I drew were not on the boundary, right? They were inside. Whereas 3 points on the boundary would be just any 3 points that are, on the border. So it could be, say, this point here, that point there, this point up here. There are a million different answers you could put. So let's say this first one was 3, 8. Then we had 5, 13. And we also had 5, 17. And describe the coordinates of the points in the region. Basically, what we're just thinking about here is like, how would you describe? So the points. So we notice that all the points are right less than x equals 5, right? Or less than or equal to, right? This is x equals 5, right? And they're all greater than or equal to x equals 3. And again, same thing with y. We have they're less than or equal to y equals 20 on top. And greater than or equal to y equals 2. So actually you don't have to write anything for this one just because we're basically going to answer it down here for D and E. So now this time what we're doing is we're kind of writing the equations from the graph. So before we were writing the, drawing the graphs based on the equations, this time it's the opposite. So it says write the inequality describing the x values. So you have to look at it, and I kind of said this already, but you have to think about what kind of equation could you use, similar to the ones, right, like here and up here, right? So, and we're writing these equations to describe just the x values at first. So, we have the x values are right going to be between. Do we see this kind of 5, right, and 3? So it would be basically that x is greater than or equal to 3, right? We see that because 3 is over here, and all the values, in this blue region here, they're greater than 3 or equal to 3, but they're also less than or equal to 5. And we do a similar thing for the y values now. So for y, we have, again, our bottom value for y is 2, right? Because all the y values are at least 2. So y is greater than or equal to 2. But it's also less than or equal to 20, right? Because that's like the top up there. Now, for writing this as a system of equations, we basically want to write it as, not in this format here, but as actual equations that you could graph. So basically, it's not so bad. We would just write this as, x. So we would say x is greater than or equal to 3, right? That's one equation. So again, you would draw like the line, right? And it's going to be anything greater than 3. But it's also going to be, x is also going to be less than 5, right? And then again, we just do the same thing for y. Y is going to be greater than 2, and y is going to be less than or equal to 20. I know it might be a little unclear why we're writing it like this, right, when we already wrote it like this up here. But basically, this isn't really the notation for a line. That's not really a line you can kind of graph. That's just kind of describing it. Whereas over here, these are specific lines that, you can, just like we did up top when you have x is greater than or equal to 3, you could draw the line x equals 3, right, and then shade in everything to the right of it. So that's kind of why we're writing it like this. So then the last question for the notes are, will the lines x equals 4 and y equals 1 pass through the region? And it wants us to draw them. So first we're going to look at the line x equals 4. So again, this is our x, right? X-axis down there. So then x equals 4 is here. And the line x equals 4 would be, let me try to draw it a little better. That's a little better. So it'd be that line, right? The line x equals 4 clearly passes through that region, right? Goes through the rectangle. So yes, for x equals 4. And let's look at y equals 1. So y equals 1, we look at the y-axis. We have the 1 down here, right? So then the line y equals 1, whoops, kind of like that. And this one, since it does not go through our little blue rectangle, that would not be in the region. So that would not be part of the solution. So no for y equals 1. All right, that's it for the notes. The independent practice problems down here are very similar to what we did in the notes. So you should hopefully be able to do them on your own with the help of this video. Again, watch that plotting lines video if you need any help with basic graphing lines. And of course, feel free to reach out to your teachers if you need any additional help. Check out the live tutoring that Digital Harbor offers from 1 to 3 every weekday as well if you need any help. And have a great week, everyone.